Hello and welcome to Polynomial and Synthetic Division. My name is Tuesday J. Johnson. I'm a lecturer at the University of Texas El Paso and an assistant professor at Doña Ana Community College. This lecture is for Math 1508 Pre-Calculus at UTEP. Chapter 2, Polynomials and Rational Functions, is coming to us from Larson's Pre-Calculus 10th edition, section 2.3, Polynomial and Synthetic Division. So let's talk about the division algorithm first of all. If f of x and d of x are polynomials, such that d of x is not 0, and the degree of d of x is less than or equal to the degree of f of x, if all of this happens, then there exist unique polynomials q of x and r of x, such that f of x is equal to d of x times q of x plus r of x, where r of x equals 0, or the degree of r of x is less than the degree of d of x. If the remainder is 0, d of x divides evenly into f of x. And that, oh my goodness. Yeah, mind-numbing. What does this really say? What this really says is, if I have f of x, and I'm dividing it by d of x, then I'll have my quotient. And after I do all my subtractions, I'll have my remainder. The d is called the divisor. The q is the quotient. The r is the remainder. And just like when we divide with real numbers, when the remainder has to be smaller than the divisor. So don't make this any more complicated than it needs to be. Don't make it as complicated as that paragraph sounds. We're simply dividing. So let's take a look at what it means to divide. I know, we have calculators. But suppose we were dividing 496 divided by 13 by hand. We would ask ourselves, what do I need to multiply 13 by to get 4? And, well, the answer is we can't. So what do we multiply 13 by to get 49? Well, the closest I could come is 13 times 3, because 13 times 3 is 39. So I'll subtract 39 from the 49 and get 10. Bring down my 6. I like to use the arrows to bring down my values because I write kind of sloppy sometimes. If you're following my videos, you already know that. So then I ask myself, what do I multiply 13 by to get super close to 106? It turns out that's going to be 8, as 8 times 13 is 104. I'll subtract the 104, 6 minus 4 gives me 2, and so I have a remainder of 2, a quotient of 38, a divisor of 13, and the 496, we were calling it f of x on the last slide, but that is called the dividend. The dividend, the thing that is inside the division. So what does this mean? It means that 496 over 13 is 38 remainder 2. Remember when you were in elementary school and you put r for a remainder? We could also write it as a fraction and put it in a mixed number. But the division algorithm says 496 is equal to 13 times 38 plus 2. So this is what the division algorithm is telling us in terms of going from division to writing the expression. Let's use this with polynomials. So if I want to divide 5x squared minus 17x minus 12 by x minus 4, so the x minus 4 is the divisor, goes outside. 5x squared minus 17x minus 12 is the dividend. And I ask myself similar questions. What do I multiply x by to get 5x squared? Well, that's right here in green. If I multiply x by 5x, I'm going to get 5x squared. Okay, so I'm going to multiply. 5x times x is 5x squared. 5x times minus 4 is a negative 20x. What did we do before? Division is just repeated subtraction, so I'm going to subtract. So I draw the line, minus sign. Draw the line, minus sign. So I want to subtract 5x squared minus 5x squared. Cancel out. If these do not cancel out, you did something wrong. Minus 17x minus a negative 20x. That's negative 17x and a positive 20x, which gives us a positive 3x. Bring down the minus 12. and I ask myself similar questions. What do I multiply x by to get 3x? Well, I'm going to multiply that by 3. So that's what I do. I take 3 times x and get 3x. I take 3 times a minus 4 to get negative 12. Draw the line, minus sign. 3x minus 3x cancels out. Negative 12 minus a negative 12, that's negative 12 plus 12, a remainder of 0. So 5x squared minus 17x minus 12 divided by x minus 4 is equal to 5x plus 3. Or we could write it in the using the division algorithm, and what we've actually done is factored 5x squared minus 17x minus 12. It's perfectly factored here as there's no remainder. Let's do it again. 6x cubed minus 16x squared plus 17x minus 6 divided by 3x minus 2. Using our color codes here, keep things straight, I ask myself, what do I multiply 3x by to get 6x cubed? Well, I know 3 times 2 is 6. I know x squared times x is x cubed, so I must be multiplying by a 2x squared. So that's exactly what I do. 2x squared times 3x is 6x cubed. 2x squared times a minus 2 is a minus 4x squared. Draw the line, minus sign. So I make sure I subtract. Negative 16x squared plus 4x squared gives me a negative 12x squared. And I ask myself, what do I multiply 3x by to get a negative 12x squared? Well, that must be a minus 4x. And so I do just that. Minus 4x times 3x is a negative 12x squared. Minus 4x times a negative 2 gives me a positive 8x. Draw the line, minus sign. When I subtract my x squareds, they cancel out. It's exactly what I wanted, so I know I'm on track. 17x minus 8x gives me 9x. Bring down the 6. 9x minus 6, what do I multiply 3x by to get 9x? I multiply it by 3. So I do just that. 3 times 3x is 9x. 3 times a minus 2 is a minus 6. Draw the line, minus sign. When I subtract, I again get 0. You'll notice many of my examples end with a remainder of 0. That does not happen in general. I just so happen to pick some examples that work out really well. So what does this tell us? It tells us that 6x cubed minus 16x squared plus 17x minus 6 is written as 3x minus 2 times 2x squared minus 4x plus 3. It looks like I had that sign written wrong there. Put a little fix on that. If you've seen my notes on my website through UTEP, sorry about that error. I'll try to remember to correct it. Use long division to divide. We actually have a difference of cubes and a sum of cubes formula for factoring, but if you don't remember it, you can use long division to figure out what the factors are. So if I take x cubed plus 125 and divide it by x plus 5, my x cubed and all the spaces down in descending order, 0x squared plus 0x plus 125 is my dividend, and x plus 5 is my divisor. These zeros help me keep my place value. Just like if I was writing the number 1001, I would include a couple of zeros in there, right, in between the ones. I'm going to include zeros when I do my division as well. It's a great habit to get into, especially for what comes next. And I ask myself the same questions. What do I multiply x by to get x cubed, and that's x squared? I do my multiplication, draw the line, minus sign. When I subtract, I get negative 5x squared, and I'll bring down my 0x. I ask myself, what do I multiply x by to get minus 5x squared, and that happens to be a negative 5x, so I multiply. Draw the line, minus sign. When I subtract 25x, bring down the 125. What do I multiply x by to get 25x? I multiply by 25, so I do so. Draw the line, minus sign, and I get a remainder of 0, and I have how to factor the sum of cubes when it's x cubed plus 5 cubed. That is x plus 5 times x squared minus 5x plus 25. Now, long division of polynomials is nice, but it gets long sometimes. If you have a 4th or 5th degree polynomial, it could go forever. Synthetic division, and here we have for a cubic polynomial, but you can use synthetic division on any power of a dividend polynomial. But if I want to divide ax cubed plus bx squared plus cx plus d by x minus k, and it must be a linear term, we're going to use the following pattern. So we'll put our k on the outside. All right, so I set x minus k equal to 0, x equals k is what I'm going to put as my divisor. I'll list my coefficients a, b, c, and d, leaving space. The pattern is your a value always drops down. And then you're going to multiply by k to move up and over, add straight down. Multiply by k to move up and over, add straight down. Multiply by k to move up and over, add straight down. Let's do some examples. For 3x cubed minus 17x squared plus 15x minus 25, if I want to divide by x minus 5, I'm going to set x minus 5 equal to 0 and get x equals 5. That's the value I use in my little box. Write down my coefficients, 3, negative 17, 15, and negative 25. Leave a space, draw a line. All right, so the first number drops down. 3 just comes down. Now I multiply to go up and over. 3 times 5 is 15, and then I add straight down. Negative 17 and 15 is negative 2. Multiply by 5 to go up and over. Add straight down. 15 and negative 10 is 5. Multiply to go up and over. 5 times 5 is 25. Add straight down. And yes, another remainder of 0. Very boring. But what does this tell us? This last value will always be your remainder. Since our original polynomial started as x cubed, and we're dividing by a single power of x, a linear term, a third power and a first power, when I divide those, I'm going to have a result that is a second power. So I'll have 3x squared minus 2x plus 5 with a remainder of 0. Q of x is always 1 degree less than f of x in synthetic division because we always divide by a linear first power term. Again, 5x cubed plus 18x squared plus 7x minus 6 divided by x plus 3. You set x plus 3 equal to 0 to get x equals negative 3. Write down our coefficients, 5, 18, 7, negative 6. Leave a space, draw a line. We're going to bring down the first number, 5, always. 5 times negative 3 is negative 15. Multiply to go up and over. Add straight down. 8 and negative 15 is 3. Multiply to go up and over. Negative 3 times 3 is negative 9. Add straight down. 7 and negative 9 is negative 2. Multiply negative 3 times negative 2 to go up and over. 6. Add straight down. And yes, another remainder of 0. So we'll have a remainder of 0. This was a cube. So my answer, my quotient, is going to be a square. 5x squared plus 3x minus 2. Negative x cubed plus 75x minus 250, all divided by x plus 10. I'm going to set x plus 10 equal to 0, and I'll get x equals negative 10. Don't forget to fill in your zeros as necessary. I have no squared term in the dividend in the original function, in the original polynomial. So I'm going to put in a 0 as an x squared location. In long division of polynomials, the 0 is a good idea just to keep everything organized. In synthetic division, a 0 is absolutely necessary. You can choose to do it with long division. You must do it with synthetic division. If you don't have this 0, your answer is going to be totally off. So make sure you fill in every power, starting with x cubed, x squared, x constant term. Make sure you have everything on the way down. And again, I have a remainder of 0, minus x squared plus 10x minus 25 with a remainder of 0. Pause if you want to work through it and make sure you get the same answer. Alright, so all this division, why do we care? What's going on here? Let's look at a couple of theorems. First of all, the remainder theorem. If a polynomial f of x is divided by x minus k, the remainder is r equals f of k. Alright? The factor theorem. And the factor theorem is a corollary of the remainder theorem, and a corollary means it comes from the remainder theorem. The factor theorem says a polynomial f of x has a factor of x minus k if and only if f of k equals 0. But remember, f of k is the remainder, so a polynomial has a factor if the remainder is 0, and I know the remainder is 0 by evaluating by k. Let's check it out. Let's see how we could use this remainder in synthetic division. So the remainder r, which remember is not always 0, obtained in the synthetic division of f of x by x minus k, provides the following information. So all of this information is kind of the same. If I talk about one, it also means the others. So the remainder gives the value of f at x equals k. If the remainder is 0, x minus k is a factor of f. And if the remainder is 0, k comma 0 is an x-intercept of the graph of f. So if we find factors, we're finding zeros. If we're dividing, we don't have factors and there's a remainder, we're actually evaluating a function. There's a lot going on here. So let's write f of x, which is equal to x cubed minus 5x squared minus 11x plus 8, in the form of x minus 4 times some quotient with a remainder. And then we're going to demonstrate that f of k equals r. Now, it doesn't tell us what k is, but remember, the form itself is asking us to divide by x minus 4. It's telling us what our divisor is. If we're dividing by x minus 4, a factor of x minus 4, which looks like this, if we set that equal to 0, we'll get x equals 4. X equals 4 is the exact thing that we're dividing by. So I'll write down 4 is what I'm dividing by. 1, x cubed minus 5x squared, negative 11, and 8. And here in the top of those, I've written down the power, so I make sure I have everything along the way. Synthetic division drops the first number, so that's 1. 1 times 4 is 4, multiply to go up and over. Add straight down, negative 5 and 4 is a negative 1. Multiply to go up and over. Add straight down, negative 15. Multiply to go up and over, negative 60. Add straight down, negative 52. So if I started with an x cubed and I divide by a linear term, my quotient will start with x squared. That's 1x squared minus x minus 15 with a remainder of negative 52. Now, this first part of the question is finished. We need to demonstrate that f of k is equal to r. Well, f of k, our k value was 4. That's what we were dividing by using synthetic division. So if I evaluate this polynomial at 4, I'll have 4 cubed, which is 64, minus 5 times 4 squared, so that's minus 5 times 16, minus 11 times 4, which is negative 44, plus 8. 64 minus 80 minus 44 plus 8. If I add the positive values, 64 and 8, I'll get 72. If I add the negative values, negative 80 and negative 44, I'll get a negative 124. And what do you know? When you add those together, 72 and negative 124, you'll end up with negative 52. That was our remainder. F of 4 is equal to negative 52. The remainder is negative 52. And now you have to ask yourself, all right, if I don't have a calculator, would I rather do synthetic division to evaluate a function, or would I rather have to do all of these little multiplications and powers and combining? Remember, no calculator? I'd probably take synthetic division. So let's use the remainder theorem and synthetic division to evaluate the function g of x equals 2x to the 6th plus 3x to the 4th minus x squared plus 3 at g of 2. Well, I have 2x to the 6th, 0x to the 5th, 3x to the 4th, 0x cubed minus 1x squared plus 0x plus 3. I leave a space, I draw a line, and I'm starting to think I need to get batteries for my calculator. Maybe I'd rather evaluate the polynomial. I don't know. We're dividing by 2, so I'll bring down the original 2, right? A coefficient of x to the 6th drops down. Multiply to go up and over and add straight down. Multiply to go up and over, add straight down. Multiply by 2 to go up and over, add straight down. multiply by a 2 to go up and over, add straight down. It's nice that it's a 2. It's easy to multiply by 2. If this were a 7, I don't know that I would be using this method at this point. 43 times 2 is 86. When I add it to 0, it's 86. 86 times 2 is 172 plus 3. I just evaluated my function. G of 2 is equal to 175. Ones, twos, this is a great way of doing it. Much else, and I don't know that I would want to multiply, say, 86 by -7, 5, larger values. Same polynomial, if I wanted to evaluate at g of -1, I still have all my zeros in. Negative 1s are also easy. Drop down the 2, multiply by a -1. 2 times -1 is -2. 0 and -2 is -2. All I'm doing when I multiply by -1 is changing the sign as I move up and over. 3 plus 2 is 5. Multiply to get -5, add straight down. Multiply to get +5, add straight down. Multiply to get -4, add straight down. Multiply to get +4, add straight down, and it turns out that g of -1 is equal to 7. Polynomial and synthetic division. We're going to use it when we're talking about zeros of polynomials.